Intro. Hello everyone. Welcome back to our channel. Today, we have an exciting topic lined up for you, especially for those of you who are interested in artificial intelligence and machine learning. We're diving deep into the world of scalable AI model deployment pipelines. We'll explore how to take your AI models from initial development through to production using continuous integration and continuous deployment, or CI/CD, automation. As AI and machine learning continue to evolve, it's essential to have a robust pipeline that not only supports your model development but also ensures that your models can be deployed, maintained, and updated seamlessly in a production environment. So, grab your notebooks and let's get started. Section 1: Importance of a deployment pipeline. Before we delve into the nuts and bolts, let's first understand why a deployment pipeline is crucial. In the context of AI and machine learning, a deployment pipeline serves as the backbone of the entire model lifecycle. Once a model has been trained and optimized, the next step is deployment, where it's used to generate predictions in real-time or batch modes. A well-structured deployment pipeline allows for rapid iteration, making it easier to test new models and features. It also provides mechanisms to roll back changes if new versions of the model do not perform as expected, ultimately ensuring stability and reliability. Furthermore, it helps teams maintain consistency between development and production environments, reducing the "it works on my machines" syndrome that often plagues software development. Section 2: Overview of the pipeline stages. Now that we've established the importance of a deployment pipeline, let's break down the stages involved in building a scalable AI model deployment pipeline. The stages typically include 1. Model development. 2. Model training. 3. Model validation. 4. Model deployment. 5. Monitoring and maintenance. Each of these stages plays a vital role, and we'll discuss each one in detail to provide you with a comprehensive understanding. Section 3: Model development. The first stage is model development. This is where data scientists and machine learning engineers work on creating the model. This involves selecting the right algorithms, pre-processing the data, feature engineering, and tuning hyperparameters. When developing your model, it's essential to keep scalability in mind. This means organizing your code effectively, ensuring that it's modular and reusable. It's also a great idea to use version control systems like Git for tracking changes in your codebase. This way, you can easily collaborate with team members, manage changes, and revert to previous versions if necessary. Using a platform like Jupyter Notebook or Google Colab can also be beneficial during this stage. They allow for interactive development and exploration of your data, making it easier to visualize results and iterate quickly. Section 4: Model training. Once your model is developed, the next step is model training. This stage involves feeding your model with training data, allowing it to learn patterns and relationships. In practice, this may involve running multiple experiments with different datasets or configurations to identify which model performs best. For scalable training, consider using cloud-based solutions like AWS, GCP, or Azure. These platforms provide powerful resources that allow you to leverage GPU or TPU instances, significantly speeding up the training process. Additionally, tools like TensorFlow and PyTorch offer built-in functionalities for distributed training, which can scale your processes across multiple nodes. It's also essential to automate this process. Using tools like Apache Airflow or Prefect, you can create workflows that automatically trigger training jobs whenever new data is available or when model parameters are updated. This ensures that your model is always trained on the latest data, improving its accuracy and reliability. Section 5: Model validation. After training, we move on to model validation. This is a critical stage where we evaluate the performance of our model using a separate validation dataset. The goal here is to ensure that the model is not only accurate but also generalizes well to unseen data. During validation, it's important to track various performance metrics such as accuracy, precision, recall, and F1 score. You might also want to implement cross-validation techniques to ensure that your model is robust. Automation can also play a significant role here. Tools like MLflow or DVC, data version control, can help you manage and track your experiments, making it easier to compare different model versions and select the best one for deployment. This automated tracking and comparison will save you a lot of time and effort when it comes to finding the right model. Section 6, Model Deployment. Now that we have a validated model, it's time for deployment. Deploying a model can take various forms, depending on the requirements of your application. It could be a REST API, a batch processing system, or even an embedded system in a smart device. For scalable deployments, containerization is a powerful approach. Docker is the most widely used tool for this purpose. By containerizing your model, you can ensure that it runs consistently across different environments, from development to production. Docker allows you to package your model along with all its dependencies, making deployments smoother and reducing compatibility issues. Once your model is containerized, orchestrating these containers is the next step. Kubernetes is a popular choice for managing containerized applications. It automates the deployment, scaling, and management of containerized applications, ensuring that your model can handle varying loads efficiently. Section 7, CI/CD Automation. Now that we have our model deployed, we can't forget about continuous integration and continuous deployment, or CI/CD. CI/CD is a set of practices that aim to improve software development processes through automation. In a CI/CD pipeline, whenever a change is made to the code, it triggers an automated CI process. This process typically includes running tests, validating code quality, and building the application. Once the code passes these checks, it can be automatically deployed to production through the CD process. For AI models, CI/CD automation can include additional steps such as retraining the model based on new data or deploying updated model versions. Tools like Jenkins, GitLab CI, and Circle CI can be integrated to handle these automation tasks effectively. Another critical aspect of CI/CD is the ability to perform A/B testing and canary releases. These strategies allow you to deploy new versions of your model to a small subset of users first, ensuring that everything functions correctly before a full rollout. This mitigates the risks associated with deploying untested models and provides a safety net for your application. Section 8, Monitoring and Maintenance. Finally, once your model is in production, continuous monitoring and maintenance are vital. You want to ensure that your model is performing as expected in real-world conditions. Implement monitoring tools like Prometheus, Grafana, or ELK Stack to track model performance, resource utilization, and system health. Monitoring should include not only performance metrics but also drift detection. Model drift occurs when the statistical properties of the model's input data change, potentially degrading its performance over time. Having monitoring tools in place will help you detect drift early and trigger retraining processes as necessary. Additionally, maintain a feedback loop from end users to gather insights on the model's performance in different scenarios. This feedback can guide future iterations and improvements of your model, ensuring that it remains relevant and effective. Conclusion. So, there you have it. Building a scalable AI model deployment pipeline requires thoughtful planning, strategic use of automation, and continuous monitoring. By following these stages, from model development to deployment and monitoring, you can create a robust pipeline that supports not only the initial deployment of your AI models but also their ongoing maintenance and improvement. As you embark on your journey to build scalable AI pipelines, remember that every organization is different. Tailor these practices to fit your specific needs and constraints. CI/CD automation, in particular, can be a game changer, enabling you to innovate faster and deliver better results. Thank you for tuning in today. If you found this video helpful, please give it a thumbs up, share it with your peers, and don't forget to subscribe to our channel for more content on AI and machine learning. If you have any questions or comments, let us know in the comments section below. Until next time, keep building, keep innovating, and stay curious.